Welcome back, my fans. Welcome back to my channel for education. My channel for education and universe and space. The topic today is O for universe. Let's go. Just wake me and follow me and support me. I am Kostadin Volkov. I am here for you, for your edu- education. Let's go. Science in space. This is the topic tonight. In the decides following the first Sputnik and Explorer satellites, the ability to put their instruments into outer space give scientists the opportunity to acquire new information about the natural universe, information that in many cases would have been unobtainable any other way. Space science added new dimension to the quest for knowledge, completing and extending what had been giant from centuries of the theoretical speculations and ground-based observations ground-based observations. After Jaring's 1961 flight space mission involving human crew carried out a range of significant research. From one side, geologic investigations on the moon to a wide variety of observations and experiments aboard orbiting spacecraft. In particular, the presence in space of human as experiments and in some cases as experimental subject facilitated studies in biomedicine and materials science. Nevertheless, most space science was and continues to be performed by robotic spacecraft in Earth orbit in other location from which they observe the universe, or on missions to various bodies in the solar system. In general, such missions are far less expensive than those involving humans and can carry sophisticated automated instruments to gather a wide variety of relevant data. In addition to the United States and the Soviet Union, several other countries achieved the capability of developing and operating scientific spacecraft and thus carrying out their own space mission. They include Japan, China, Canada, India, and a number of European countries, such as the United Kingdom, France, Italy, and Germany, acting alone and through cooperative organizations, particularly the European Space Agency. Furthermore, many other countries become involved in space activities through the participation of their scientists in specific missions, bilateral of multilateral cooperation between various countries in carrying out space science mission grew to be usual way of proceeding. Scientific research in space can be divided into five general areas. 1. Solar and space physics, including study of the magnetic and electromagnetic fields in space and the various engineering particles also present, with particular attention to their interactions with Earth. Number 2. Exploration of the planets, moon, asteroids, comets, meteorites, and dust in the solar system. Number 3. Study of the origin, evolution, and current state of the varied objects in the universe beyond the solar system. Number 4. Research on non-living and living materials, including humans, in the very low gravity levels of the space every moment. And number 5. Study of Earth from space. The first scientific discovery made with instruments orbiting in space was the existence of the Van Allen radiation belt discovered by Explorer 1 in 1958. Subsequent space mission investigated Earth's magnetosphere, the surrounding region of space in which the planet's magnetic field exerts a controlling effect. Of particular and ongoing interest has been the interaction of the flux of charged particles emitted by the sun, called the solar wind, with the magnetosphere. Early space science investigations showed, for example, that luminous atmospheric displays, known as auroras, are the result of this interaction, and the scientists came to understand that the magnetosphere is an extremely complex phenomenon. The focus of inquiry in space physics was later extended on understanding the characteristic of the Sun, both as a average star and the primary source of energy for the rest of the solar system, and to exploring space between the Sun and Earth and other planets. The magnetospheres of the planets, particularly Jupiter with the strong magnetic field, also come under study. Scientists search a better understanding of the internal dynamics and overall behavior of the Sun. The underlying case of the variations in solar activity and the way in which those variations propagate through space and ultimately affect Earth's magnetosphere and upper atmosphere. The concept of space weather was advanced to describe the changing condition in the Sun-Earth region of the solar system. Variations in space weather can cause geomagnetic storm that interfere with the operation of satellites and even systems on the ground, such as power grids. To carry out of the investigation required of addressing this scientific question, the United States, Europe, the Soviet Union, and Japan developed a variety of space missions, often in a coordinated fashion. In the United States, early studies of the Sun were undertaken by a series of orbiting solar observatory satellites launched 1962-75, and the astronaut crew of the Skylab space station in 1973-74 using that facility. Apollo telescope mount. These were followed by the Solar Maximum mission satellite launched 1980. ESA developed the Oasis Mission 1990 to explore the sun power region. Solar terrestrial interaction were the focus of many of the Explorer series of spacecraft. 1958-75 and the orbiting geophysical observatory satellites. In the 1980, NASA, ESA, and Japan's Institute of Space and Astronation Science undertook a cooperative venture of develop a comprehensive series of space missions, named the International Solar Terrestrial Physics Program, that would be aimed at full investigation of the Sun-Earth connection. This program was responsible for the USA Wind 1994 and Power 1996 spacecraft, the Europe Solar and Heliospheric Observatory SAHU 1995 and Quastar 2000 mission, and Japan's Geotel satellite 1992 years. Among many other missions, NASA has launched a number of satellites, including thermosphere, ionosphere, mesosphere, energetics, and dynamics. Timed 2001, the Japan's USA United Kingdom collaboration. High Note 2006 and Solar Terrestrial Relation Observatory. Stereo 2006, part of this Solar Terrestrial Probes program, the Solar Dynamic Observatory. 2010, the Twin Van Allen probes. 2002, 12, and the Parker's Solar Probe. 2000, which made the closest flybys of the Sun, were the part of the another NASA program called Living with a Star, a two-satellite European-Chinese mission called Double Star. 2003-2004 studies the impact of the Sun on Earth every moment. From the start of the activity, scientists recognized that spacecraft could gather scientifically valuable data about the various planets, moons, and smaller bodies of the solar system. Both the United States and the USSR attempted to send robotic missions to the moon in the late 1950s. The first four Pioneer spacecraft, Pioneer, launched in 1958, were not successful in returning data about the moon. In the 1960s, the United States became the first country to send a spacecraft to vicinity of the other planets. Mariner 2 flew by Venus in December 1962 and Mariner 4 flew past Mars in July 1965. Among significant accomplishments of the planetary mission in succeeding the site where the US Viking launched landings on Mars in 1976 and more data. Early on, scientists planned to conduct solar system exploration in three stages: initial reconnaissance from the spacecraft flying by a planet, comet, or asteroid, detailed surveillance from a spacecraft orbiting the object, and the site research after landing of the object, or, in the case of the giant gas planet, by sending a probe into its atmosphere. All three of those stages have been carried out for the Moon, Venus, Mars, Jupiter, Saturn, a comet, and several asteroids. Several Soviet and USA robotic spacecraft have landed on Venus and the Moon, and the United States have landed spacecraft on the surface of Mars. A long-term detailed surveillance of the Jupiter and the Moons began in 1995 when the USA Galileo spacecraft took up orbit around the planet at the same time, releasing a probe into the turbulent Jovian atmosphere. In 2001, the USA Near Earth asteroid Rendezvous near spacecraft landed on the asteroid Eros and transmitted information from its surface for more than 2 weeks. Among the rocky inner planets, only Mercury was for some time relatively neglected in the first half century of the space exploration. Here have more information about these spacecraft missions. Missions landed from this country. These exploratory missions sought information of the origin and evolution of the solar system and the various objects that is comprises including chemical composition, surface topography, data on magnetic fields, atmospheres, and volcanic activity, and particularly for Mars, evidence of water in the present or past, and perhaps even though extraterrestrial life in some form. What has been learned to, to date confirms that Earth and the rest of the solar system formed at about the same time from the same cloud of gas and dust surrounding the Sun. The four outer giant gas planets are roughly similar in size and chemical composition, but each has a set of moons that differ widely in their characteristics, and in some way they and their satellites resemble miniature solar systems. Ladies and gentlemen, this is short information about solar systems. This is short information. We give this information from our mission to present day. Our mission of government space against here on our home planet Earth. Maybe in short future we will know everything about our solar systems. Our information to be complete and contain here on Earth. All information acknowledged for solar system will be complete. Thank you in rewards again. Thank you watch me. See you around in my channel. I'm Kostadin Valkov. Thank you again and bye. Bye for tonight. Bye bye. Just like me and share my videos. Thank you in rewards and please support me. Bye bye. See you around.